a set of checkpoint questions from yesterday's packet. So let's go over these. How does oogenesis differ from spermatogenesis with regard to the number of gametes produced, the timing of gamete production? So we said yesterday and on Tuesday that sperm production in males is a lot more simple and a lot more sperm are produced than ovum production in females, okay? We also said that the arrested meiosis was a difference that we saw in females. So remember that oogenesis was arrested, meiosis 1 was arrested at the time of birth. The female was born with all of the eggs that she would have. They were arrested up until puberty, and then every month as she ovulated, that ovum would continue on, finish up meiosis 1, and then be arrested in meiosis 2 unless that ovum was fertilized. Okay, so that's what happened in females. So we had a set number of pool or a set pool of gametes in females. We also have a very timed kind of interrupted meiosis 1 and meiosis 2. In males, we see constant production of spermatocytes, right? We had 2 spermatogonium, which are the premature, the primordial gametes, and every couple of hours, actually, males are continually producing sperms. So every time we have those 2 spermatogonium, only one continues on to become sperm, and the other one stays behind to reproduce that pool. So there's an unlimited production of spermatocytes in males as opposed to what we see in females. So the number differs greatly as well as the timing, right? There's a constant production versus that interrupted meiosis 1 and meiosis 2. So that kind of leads into question 2. When do meiosis 1 and meiosis 2 occur in oogenesis? So again, just to clarify here, meiosis 1 happens before birth and is arrested up until the time of puberty. Meiosis 1 continues at puberty, that's what ovulation is. And then meiosis 2 is arrested unless that ovum is fertilized. If that ovum is fertilized, then meiosis 2 proceeds. So we don't fully divide or we don't fully mature ovum unless fertilization takes place. Question 3, identify the 2 phases of the ovarian cycle and briefly describe the events that occur in each. So the ovarian cycle had the follicular phase and the luteal phase. The follicular phase was the first 14 days. The luteal phase was the day 15 to 28. In the follicular phase, just to kind of summarize here, we're going to go over this a little bit later, but the follicular phase is where we have the development of the primordial follicles, and then eventually only one became the mature Graafian follicle. And it had certain features that made it unique, distinguished from the other primordial follicles that would eventually regress. In this time, we also have the development of the uterus. So that'll be the uterine cycle, but make sure that you're correlating what's happening in these 2 areas. In the luteal phase, which is the second half of the ovarian cycle, we see the rupturing of the Graafian follicle, the ovum separates from the rest of the follicle stays behind and becomes the corpus luteum, and that sticks around for about 10 days, and it is under the influence of estrogen and progesterone that's coming from the fertilized ovum, and so if it doesn't have that HCG coming from that fertilized ovum, it's going to regress, okay? The uterine cycle now had 3 different phases. There's the menstrual phase, the proliferative phase, and then the secretory phase. The menstrual phase was the sloughing off, about day 1 to 5, the sloughing off of the uterine lining. The proliferative phase was the building up of a new lining in hopes of a new fertilization. And then the secretory phase was the actual ripest stage of the ovarian lining, again, preparing for that implantation.